right, these last few problems here, we still have to draw pictures for. So it says an airplane is flying at an elevation of 5,150 feet directly above a straight highway. Two motorists are driving cars on the highway on opposite sides of the plane. So the plane is at a certain elevation, 5,150 feet. Plane's up here. We have one car on one side and one car on another side. They're on the straight highway. It says the angle of depression to one car is 35 degrees and the angle of depression to the other car is 52 degrees. How far apart? What is this distance? How far apart are the cars? They gave me angles of depression. I did not really draw this to scale, so ignore that part. But angles of depression, again, are out here. So they equate to angles of elevation inside of the triangle. Those are alternate interior angles. So one of these can be 35. It doesn't really matter the way I drew it. And one of these can be 52. If I can find the horizontal leg on both triangles, then I will have the total distance. So I'm going to call this one X and this one Y. And then the X plus Y will be the total distance for how far apart are the cars. All right, so for the 35-degree triangle, we have opposite adjacent. So it's going to be tangent of 35 degrees equals 5,150 divided by x. The other triangle is going to be the tangent of 52 degrees equals 5,150 divided by y. And we need to figure out x and figure out y. So if I solve this for x, I multiply x to the left side, I divide by tangent of 35. So that would be 5,150 divided by tangent of 35. And similarly, y will be equal to 5,150 divided by tangent of 52. And I think I said this in the previous video, but you could do this for your AP exam as well. If it's clear that x is equal to this and y is equal to this, I could just say something like the total distance or the distance between the cars, whatever, is equal to x plus y. So I don't have to write this plus this again. I can just say x plus y and say what that is approximately equal to. All right, so check your mode again. We should be in degree mode, which we are. If you're not, press mode, go down here and make sure degree is highlighted and press enter. So 5,150 divided by the tangent of 35 degrees. And then we're adding to that 5,150 divided by the tangent of 52 degrees. And we get 11,378.583. And this is measured in feet because that's what the elevation was measured in. All right, now the next question says if both cars in exercise 56 are on one side of the plane, and for some reason, I don't know if this is a typo or what, but they changed this angle to 38 degrees and 52 degrees. So it was 35, 52. So just kind of be aware of that. So that changes our picture a little bit. Now the plane is, I'm going to put it over here. Now the plane is on one side and the two cars are on the same side of that plane. So one car could be here, for example, and the other car could be out here. And we have angles of depression again. So now here it does kind of matter which one you put where. The car that's closer needs the larger angle of depression. So this angle right here would have to be 52 degrees. So I'm going to put that here. That's the steeper angle. The angle that's not as steep is out here. That's going to be 38. So those are angles of depression. But remember, we put them down as angles of elevation because they are equivalent. All right, I'm still going to call this side x, this short side, but I don't want to say that this is y, like between car 1 and car 2, because that's not a right triangle. The larger leg for that 38-degree angle is this entire distance. So let's call that y. And then to get my solution, the distance between the two cars is going to be whatever y is minus whatever x is. All right, so set up the x first. So using tangent again, because we have opposite and adjacent, the tangent of 52 degrees is equal to 5,150 over x. And I can solve that for x. And then I can solve a similar triangle for y. So I can say the tangent of 38 degrees is equal to 5,150 divided by y. So again, y is 5,150 divided by tangent of 38 instead of just tangent of 35 like before. And just like I did before, the distance between the two cars is going to be equal to y, the larger value, minus x, and that's approximately equal to divided by tangent of 52. Close parentheses around the angle, so the calculator knows that the subtraction is not part of that inside of that tangent. Oops, and I just typed this in backwards. Sorry. Pay attention to what's x and what's y. So y is tangent of 38 degrees, and x is the tangent of 52 degrees. So subtracting those, in this case, the cars are 2,568.078 feet apart. All right, number 58. A hot air balloon is floating above a straight road. To estimate their height above the ground, the balloonists simultaneously measure the angle of depression to two consecutive mileposts, angles of depression, on the same side of the balloon, so kind of like the last picture. And the angles of depression are 20 degrees and 22 degrees. How high is the balloon? So again, I'm going to draw that same scenario. So angle of depression to 1 mile marker, angle of depression to another mile marker. And that term mile marker is actually really important. Let's put our angles in here first. Oops, 22 degrees, the bigger angle has to be the steeper one right there. That's 20. Notice that you don't have any numbers for how many feet apart anything is, but if these are mile markers, it means that they literally are 1 mile apart. So if this is mile marker 1 and this is mile marker 2, this distance here is 1 mile between them. Now, I don't know how far they are from the spot underneath the hot air balloon. We don't actually know that. We do know that that's 1 mile. Okay. We don't know the altitude. Let's call that x. We do have this 1 mile here, and we don't know the other leg right here. Let's call that y. Now, remember, you have a small triangle and you have this larger triangle. And this dimension would be y plus 1. So I'm still going to set up a tangent equation for each scenario. For the first angle, tangent of 22 degrees is equal to, all I can say is that it's equal to x over y. And then for the other one, the tangent of 20 degrees is equal to x over y plus 1. All right, and the question is, how high is the balloon? So how high is this? And I'm realizing as I'm making this video, I might have switched what I called X and Y on my answer key versus this. So actually, I want to switch that because I don't want that to be confusing. Let me flip those things around. Let's make this Y. Let's make this X. X plus 1. I'm not sure if I did that or not. I guess I could probably check, but I think this is right. Okay, so just to try to keep things consistent. So you have two options for how to solve this. We're trying to find y. So the way I like to solve these problems is whatever I'm trying to find um, needs to stay in the equation when I set the two sides equal to each other. So the first step here is to multiply the x to the other side in both equations. This is x plus 1 to the other side. And at this point, I could set the two equations equal to each other. But when I solve that, I'll be solving then for x, because x will be the only variable. And then I'll have to go back and do some extra work to find what y is, because y is my end goal. So instead of setting them equal to each other right here, let's solve these for x. I can say x equals y divided by the tangent of 22 degrees. And I'm going to divide by tangent. X plus 1 equals y divided by tangent of 20. And subtract 1. So x equals y divided by tangent of 20 degrees minus 1. So now I have the equation so that they're both x equals, and then when I set them equal to each other, then I only have y's left in the equation. And that's what I want to solve for anyway. So this is just one way to do this. All right, now I have an equation that I want to solve for y. We saw this with our logarithm equations a couple months ago. When you have two different terms with the variable that you're trying to solve for, get them on the same side. So I've subtracted the 1. Factor out a y. That would make this 1 over tangent of 22 minus 1 over tangent of 20. That's equal to negative 1. And then you can divide by that entire parentheses. So again, that should be a little bit familiar because we did do it back with logarithms, but I know it's been a while. And it looks a little scarier with trig, but we've got calculators. So the rest of this is just me typing this into my calculator. So I do have to be careful with parentheses. Remember, you've got to tell the calculator that all of this is in the denominator. So when I get down to this, I'm going to say y is approximately equal to, let's see, so negative 1 divided by, parentheses for the denominator, 1 divided by tangent of 22, close that angle, and then minus 1 divided by tangent of 20, close that angle, close the parentheses around the denominator, and press enter. And so I get that y is equal to 3.671. And this is measured in miles because the 1, the only number we had here, was the 1 mile between those two. What is the alternative way to solve this? Let's go back from this step here. All of us have to start out with the first step that I did. Set up your two tangent equations, multiply your x's over. So maybe you do what I said back in the beginning. Well, these are both equal to y, so let's just set them equal to each other. So this is another thing you can do. I'm going to set x plus 1 times tangent of 20 on this side, and I'm going to distribute the tangent 20. So that would be x times tangent of 20 degrees plus 1 times tangent of 20 degrees. And then I still have to do the same thing I did with the y's. I need to get the x's on the same side. So I subtract x times tangent of 20 degrees. And then I need to factor an x out. All right, and then I need to divide by the parentheses. So you have to be careful with this because this is not your final answer. This is going to find an answer for x. So that's the reason I try to use the other way, even though it gives me some weird fractions and stuff. This is not my final answer. This is just what x is equal to. Remember, the question is, how high is the balloon? So the question is, what is y? And you do have a formula for y here. Right back here. Y is equal to x times the tangent of 22 degrees. So once I figure out what x is, I can also say times tangent of 22, and then that will find what y is equal to. So let me split screen this over here. So first I'm going to type in x. So this was tangent of 20 divided by parentheses, tangent of 22, close the angle, minus tangent of 20, close the angle, close the parentheses in the bottom. This is x times the tangent of 22 degrees. So I do get the same answer, 3.671 miles. It does not matter to me which way you do it, and I really don't think that one way is that much longer or that much shorter than the other. So it's just whatever makes sense to you is totally fine. All right, another one of these that's kind of similar. So this says to estimate the height of a mountain above a level plain, the angle of elevation to the top of the mountain is measured to be 32 degrees. 1,000 feet closer to the mountain, it's found that the angle of elevation is 35. Okay, so first let's come up with that first scenario. We're looking up at a mountain. Here's the mountain. Here's our 90-degree angle. Angle of elevation is 32 degrees. And then when we get 1,000 feet closer to the mountain, so say that's here, this is 1,000 feet. Now if we look up at the mountain, the angle should be a little bit taller, and it is. It's 35 degrees. And the question is, how tall is this mountain? So let's call that y again. So I kind of have the same scenario as the last one now. So I've got two right triangles. I've got a big one and a smaller one. I'm going to call the leg of this smaller one x. I don't know how close we are to the mountain at that point. But I do know that this large leg from where we started to the mountain, now I know that that's x plus 1,000. So again, you can solve this problem in two ways, but you have to start the same way no matter what. Start with two tangent equations. The tangent of 32 degrees equals opposite y over adjacent, which is x plus 1,000. And the tangent of 35 degrees is equal to y over x. Let's get the x out of the denominator. I'm going to go ahead and, well, no, I'm not. I'm going to keep this in parentheses. Indecisive there. And I'm going to multiply the x over here. Okay, so again, I could set these equal to each other at this point, find x, and then use that to find y. But remember, you're ultimately trying to find y. So I like to rearrange this like I did last time, and I'm just going to say, well, let's get x by itself so that we can keep y as the input variable in the equation. So if I want to do that, then I'm going to divide the tangent of 32 over to the right side of the equation and subtract 1,000. So x is equal to y divided by the tangent of 32 minus 1,000. And then over here, x is equal to y divided by the tangent of 35 degrees. So then I can set my equations equal to each other. And then I need to get my y's on the same side. It doesn't matter which side. I'm going to move them to the right side since the negative 1,000 is already on the left. So it's negative 1,000 equals y times tangent of 35 minus y, not times, divided by tangent of 32. This allows me to factor out a y. That's going to make this 1 over tangent of 35 minus 1 over tangent of 32. And again, we divide by parentheses. Okay, so we hop over to our calculator. Negative 1,000 divided by parentheses for the denominator, 1 over tangent of 35, close the angle, minus 1 over tangent of 32, close the angle, close the bottom parentheses, and that's my approximation for y. So 5,807.655 feet, right? We're 1,000 feet closer, feet, is about equal to y. Y is the height of the mountain, so we're saying that's about the height of that mountain. Just for time's sake, I'm not going to solve this the other way. But remember, you could have back here, you could have set these equations equal to each other. I'll give you the first step here. Distribute that tangent through. I did not leave myself enough room. Bring this over here. Okay. Set these equations equal to each other. Find x. Once you find x, remember that y is equal to x times the tangent of 35. And you should get to the same answer. All right, number 60. Sorry if you can hear the clock going there. So number 60 gives us a picture. That's exciting. To measure the height of a cloud cover at an airport, a worker shines a spotlight upward. So, okay, we're given two angles here. We're given the distance between the worker and whatever this is. Oh, the spot of light there. So, or the spotlight there. So those are 600 meters apart. We don't know how the 600 is broken up. It's not going to be even. It's not 300, 300, but let's just call this side X. And let's call this side the rest of the 600, which is 600 minus X, right? Because if this is 500, then this is 100, etc. Find H. So we'll set up some tangent equations again. The tangent of 45 degrees is equal to h over x. And the tangent of 75 degrees is equal to h over 600 minus x. It does not matter, by the way, where you put the 600 minus x. If you switched those, it's fine. We'll get the same answers in the end. I'm going to use the same trick I've been using to find h. I am going to multiply the x out. But then I don't want to get h by itself. Like I don't want to set these equations just equal to h. I want to rearrange this so I'm actually solving for x. All right, so if that was confusing, what I mean is I could, but I don't want to set the equations equal to each other right now because that'll just tell me what x is. Although actually in this one, so this is a special case. If this is 45 degrees, then this is 45 degrees. So actually x is equal to h. So, okay, so I could find x right now, and then that would be my answer for h. If this is anything other than 45 degrees, then we would have to go through this the way I'm about to. So I'm just going to keep going, assuming that I didn't notice that this is isosceles. Okay. I'm going to solve for x in both equations so that I can just get right down to finding h right off the bat. So first step is to divide by the tangent in both cases. Over here, I don't want to do this in two steps. I want to say add x over here. So it's x equals. And then let's just subtract this h term over here. So it's 600 minus h over tangent of 75. That's all legal math. Now that they're both x equals, set them equal to each other. H over the tangent of 45 degrees is equal to 600 minus h over the tangent of 75 degrees. Get your h's on the same side. So that's h over tangent of 45 degrees plus h over the tangent of 75 degrees equals 600. Factor out an h. That makes this 1 over tangent of 45 degrees plus 1 over tangent of 75 degrees equals 600. And divide by parentheses. Okay, so h is approximately equal to 600 divided by, parentheses are on the bottom, 1 over tangent of 45, close the angle, plus 1 over the tangent of 75, close the angle, close the denominator parentheses. And we get 473.205. This is labeled in meters for this one. And that is my answer for H. Now, if you go through and you found X first, you do get the same answer for X, which again is just a special case because this is an isosceles triangle, meaning it's got two sides. I don't know if I spelled that right. It's got two sides that are equal to each other because it's 45, 45, 90. If those two angles are equal, then their opposite sides are equal as well. All right, that was our last problem for the video notes. I hope that this helps. Please come see me in office hours if you want more practice or if you want me to explain any of these problems any further.